actually a converted form of solar energy. The sun's radiation heats areas on Earth differently, especially during the daytime versus the nighttime. This causes parts of the atmosphere to warm up differently. The hot air rises, causing a reduction in the atmospheric pressure at the surface of the Earth, in turn causing cool air to be drawn in to replace it, resulting in wind. Since air has mass, when it moves, it has energy of motion, or kinetic energy. When wind is used to move the blades of a wind turbine, this kinetic energy can be converted into mechanical energy or electricity, which can be captured and used to do work for our own purposes. The earliest known use of wind power is for sailing, moving people across the globe in their explorations and expansion. The first land-based windmills also included the styling of a sail for the blades. These windmills, like the ones still seen today in countries like Holland, were used to grind grain or pump water. Over the years, variations and improvements were made to perfect the functioning of the windmill. The windmills, so iconic and quintessential to the American farm, were mainly used for pumping water. In 1870, steel blades were first made that were lighter in weight and could be made into more efficient shapes. Generally, these windmills were fairly small and for individual household use, but some were larger if they were used for industrial applications, such as pumping water for steam trains. In 1888, the first large-scale windmill to generate electricity was built. In 1931, the development of a bulk power utility-scale wind energy conversion system was undertaken in Russia. Today, wind turbines come in many different styles and sizes to meet the demands they are required for.
Ideally, wind farm locations would be near a constant flow of non-turbulent wind of at least 10 miles an hour. Wind turbines either are designed to rotate about a vertical or a horizontal axis. Rotors are composed of a hub and blades mounted on the shafts. As the shafts rotate, the gearbox serves as transmissions which manage the shaft speeds for either low or high-speed rotational. The generator then converts the mechanical rotation of the shaft into electricity. The entire apparatus is then mounted upon the tower. The higher the tower, or the longer the blades, the more energy is captured. Modern wind farms can modulate the pitch or yaw of the blades to maximize the power and efficiency that is generated. Once the electricity has been generated, it can be used by any grid that the turbine or wind farm is connected to.
Will using more wind energy help with global warming? Yes. Carbon dioxide is the most important of the global warming pollutants which are changing our climate. According to experts, if we are to avoid dangerous levels of warming, we must cut our CO2 emissions by 80 to 90% by 2050. That means switching to forms of energy generation that does not produce CO2. Wind power is a clean, renewable form of energy which during operation produces no CO2. While some emissions of these gases will take place during the design, manufacture, transport, and erection of wind turbines, enough electricity is generated from a wind farm within a few months to totally compensate for these emissions. When wind farms are dismantled, about 20 to 50 years after operation, they leave no legacy of pollution for future generations. Given the scale of CO2 cuts needed, wind power, as the least expensive, most developed renewable energy technology, and the fastest to build, is the best renewable technology to deliver carbon emissions reductions on a large scale quickly.
Wind energy is the cheapest form of new electricity generation available today. Wind power is more expensive than power from old established power plants, but is cost competitive with any new power plant. Technology innovations and market building incentives have helped to dramatically lower costs over the last 20 years. When the first commercial scale wind turbines were installed in the 1980s, wind generated electricity cost up to 30 cents per kilowatt hour. Today, wind power plants can generate electricity for less than 5 cents per kilowatt hour, a price that is competitive with new coal or gas powered plants. Most of the commercial scale turbines installed today are 2 megawatts in size and cost roughly $3.5 million installed. Smaller farm turbines cost less overall, but but are more expensive per kilowatt of energy producing capacity. Wind turbines under 100 kilowatts cost roughly $3,000 to $5,000 per kilowatt of capacity. That means a 10 kilowatt machine, the size needed to power an average home, might cost $35,000 to $50,000. Community wind can contribute to the economic development of a region by providing high-quality jobs and by creating and retaining wealth that can then be reinvested in the community. For example, the wind energy sector provided 85,000 direct jobs in 2008, and the industry is expected to support up to 500,000 direct and related jobs by 2030. By keeping energy dollars circulating within the community instead of being exported to other nations or states, energy independence becomes institutionalized at the local level.
The top 10 misconceptions of wind energy are as follows. First, wind turbines reduce tourism. False. Many rural areas in the U.S. have noted increases in tourism after wind farms have been installed. Next, wind turbines create pollution. False. Air pollution has caused 159 premature deaths, 1,700 emergency room visits, and 43,000 asthma attacks every year. If we replace this energy with wind energy, it will clearly lower healthcare costs. Wind turbines cause erosion. False. Erosion can be prevented with proper installation and landscaping techniques. Wind turbines kill birds and bats. False. Wind turbines kill 1 bird out of every 10,000 fatalities, whereas 5,500 birds are killed by flying into windows, 100 are killed by cats, 800 by high-tension power lines, 700 by vehicles, and 700 by pesticides out of every 10,000. Wind turbines are an eyesore. False. Using turbines of the same size and shape and spacing them uniformly generally results in very minimal aesthetic concerns. Wind turbines make a lot of noise. False. By reducing blade thickness, the wind turbine placed 300 meters away from a residence is no louder than the reading room of a library. Wind turbines produce shadow flicker. False. It is possible to calculate very precisely whether a flickering shadow will in fact fall on a given location and how many hours in a year it will do so. In the U.S., the sun's angle is not very low in the sky, and the appropriate setback for the noise issue will be sufficient to prevent shadow flicker problems. Wind turbines throw ice. False. Placement of the turbines for noise minimizing purposes eliminates the issue of ice throwing because the turbines are very far away from residences. Stray voltage from wind power plants can be transmitted through the ground, disturbing or harming livestock. False. There is nothing different about managing electricity flow from an operating wind plant than with standard wiring practices used now. And lastly, wind turbines will interfere with TV and cell phone towers. False. Use of satellites and cable for television and cell phone transmission is not interrupted by wind turbines.